Assalamu alaikum. I'm Robir Islam. I'm a student of Department of Computer Science and Engineering, Lady University. Student ID 211-202-0031. Today I'm going to present a presentation on the history of operating system. And in this presentation, we are going to discuss different topics. Introduction to operating system, early computing and the emergence of operating system, primitive operating system, the rise of Unix, personal computers and graphical interfaces, modern operating systems, mobile operating systems, current trends in operating systems, and conclusion. Introduction to operating system. At first, let's discuss what is an operating system. An operating system is a software program that acts as an intermediary between a computer's hardware and its users. It provides a set of essential functions and services that allow users to interact with the computer and run the applications. The primary purpose of an operating system is to manage and control the computer's resources, including the processor, the memory, the storage devices, and input-output devices, and network connections. It facilitates the execution of software programs by allocating system resources, scheduling tasks, and providing an interface for the user to interact with the computer. The key component of the operating system include kernel, which is the core part of responsible for managing system resources and providing essential services, and device drivers, which allow the OS to communicate with specific hardware devices. Early computing and the emergence of operating system. Early computers were mainframe computers, and they lacked any kind of operating system. Each user had to use the machine for a scheduled period of time and would arrive at the computer with the program and data, and often the data was fed through a punched card or magnetic tapes. And at a time, only one user could use a computer, and only one program could run at a time. So the following reasons were the main reasons which led to the emergence of operating system. Number one, as computing became more complex, we needed something more efficient to manage our resources, such as the storage, the memory, etc. Also, we needed something to automate the task. We needed multiple programs to run at a time, and we also needed an improved user experience. These are the main reasons that led to the emergence of operating system. Primitive operating system. The first operating system used for real work was GMNAAIO, produced at 1956 by General Motors Research Division for its IBM 704 computer. Most other early operating systems for IBM mainframes were also produced by customers. Early operating systems were very diverse, with each vendor or customer producing one or more operating systems specific to their particular mainframe computer, which means that for each and every variation of hardware or each and every variation of hardware or each and every vendor, there has to be one specific and proprietary operating system for that specific hardware. Uh, this means that operating systems were not portable at that time, and for even for the same vendor for two different models of computers, they had to write specific and proprietary operating systems. The state of affairs continued until 1960s, when IBM, already a leading hardware vendor, stopped working on existing systems and put all its efforts into developing the System 360 series of machines, all of which use the same instruction and input-output architecture. IBM intended to develop a single operating system for the new hardware, the OS 360. In this era, there was also batch processing systems. Batch processing systems are operating systems where this system would group jobs from users together to be run in batches, and these operating systems improve the efficiency of early computing. Also, there are another type of operating system which are called time sharing systems. Time sharing systems allow users to interact with computer in real time and were capable of running multiple tasks simultaneously. Multics, IBM System 360, Model 67, and compatible time sharing system (CTSS) are some notable examples of time sharing systems from this era. The rise of Unix. The Unix operating system was developed at AT&T and Bell Laboratories in the late 1960s, originally for the PDP-7 and later for the PDP-11. Because it was essentially free in early editions, easily operable and easily modified, it achieved wide acceptance. It also became a requirement within the Bell Systems operating company. Since it was written in C language, when that language was ported to a new machine architecture, Unix was also able to be ported. This portability permitted it to become the choice for a second generation of many computers and first generation of workstation, and its use became widespread. Unix exemplified the idea of an operating system that was conceptually the same across various hardware platforms. Because of its utility, it inspired many and later became one of the roots of the free software movement and the open source software. It is because of Unix that nowadays we can enjoy these free softwares and open source softwares. Also, numerous operating systems were based on Unix, including Minix, GNU Linux, and the Berkeley uh, Berkeley software distribution, which is also known as BSD. Apple's macOS is also based on Unix via NextStep and FreeBSD. Personal computers and graphical interfaces. The development of graphical interfaces brought a significant transformation to a computer interaction. GUIs replaced traditional command line interfaces with visual elements such as icons, windows, menus, making computing more intuitive and user friendly. The introduction of GUIs can be traced back to the Xerox Alto computer, which made its debut in the 1970s. The Xerox Alto showcased the first GUI featuring icon overlapping windows and a mouse, a desktop metaphor. Its innovative design had a profound influence on future GUI developments. However, the graphical revolution truly began with the introduction of Microsoft Windows. In 1985, Windows 1.1 was released as a graphical layer on top of MS-DOS, providing a more visual and interactive experience for PC users. MS-DOS was an already existing operating system which was built or developed by Microsoft. As time progressed, subsequent versions of Windows such as Windows 95, Windows XP, Windows 7, Windows 10 brought significant advancement in GUI design, performance, and functionality. This version introduced features like taskbar, start menu, improved graphics, increased multitasking compatibilities, further enhancing the user experience and making PCs more accessible to a wider audience. Apple also played a pivotal role in the evolution of GUIs. Apple's Macintosh, introduced in 1984, features a revolutionary GUI that incorporated elements like icons, windows, and a mouse. The Macintosh GUI was designed to be intuitive and user-friendly, setting a benchmark for future operating system designs. Modern operating systems. Modern operating systems have evolved to meet the growing demands of various computing platforms. These operating systems incorporate advanced features, improve security, and enhance user experience. Let us discuss some of the widely used modern operating systems. Windows. Windows is a widely used operating system developed by Microsoft. It has a rich history, starting with the release of Windows 1.0 in the 1985. Windows evolved over the years with significant releases including Windows 95, Windows XP, Windows 7, Windows 8, and the latest version, Windows 10. Also, recently Microsoft announced a Windows 11. Windows is known for its user-friendly interface, extensive software compatibility, and broad hardware support. It offers a wide range of features including graphical user interface, multitasking capabilities, virtual desktops, Cortana, which is a voice control assistant, and a variety of built-in apps. Linux. Linux is a free and open source operating system that originated in the 1991 with the work of Linus Torvalds. It is built on the Unix-like kernel and is known for its stability, security, and flexibility. Linux has a modular design allowing users to customize and configure the operating system to suit their specific needs. It has a strong command line interface but also offers various desktop environments such as GNOME, KDE, XFCE, and for graphical user interfaces. Linux is widely used in server environments, embedded systems, and as the foundation for other operating systems like Android. macOS. macOS is the operating system developed by Apple Inc. for their Macintosh computers. It has its roots in the macOS series of operating systems that were introduced in the 1980s. macOS is known for its sleek and intuitive user interface, seamless integration with other Apple devices, and a strong focus on multimedia and creativity. Key features of macOS include the Finder File Manager, Spotlight Search, Time Machine Backup, Siri Voice Assistant, and the Apple App Store for downloading applications. macOS also provides a Unix-based foundation, giving it robust and secure underlying architecture. Mobile operating system. Mobile operating system has transformed the way we interact with our smartphone and tablets. From the early days of keypad phones to the recent generation of Android and iOS phones, this operating system has shaped the mobile landscape. It is in this slide we will explore the development and future trends of various mobile operating systems. Android. Android was developed by Google in the most widely used of mobile operating system worldwide. Released in 2008, Android is built on the Linux kernel and offers an open source platform that supports a wide range of devices. Android provides a customizable user interface, access to the Google Play Store for app downloads, and extensive integration with Google services. It has evolved with numerous versions from Cupcake to the latest Android 13, offering enhanced features, improved security, and performance optimization. iOS. iOS was developed by Apple Inc. It is the operating system exclusive to iPhone, iPads, iPod Touch devices. It was introduced in 2007. iOS offers a seamless and tightly integrated user experience across Apple's ecosystem. iOS is known for its sleek design, optimized performance, and strong focus on privacy and security. With regular updates, iOS introduces new features, improves performance, and enhances compatibility with the latest hardware. KaiOS. KaiOS is a mobile operating system based on Linux that targets feature phones and smart feature phones. It offers smartphone-like functionalities on feature phone hardware, including support for internet browsing, messaging, multimedia playback, etc. KaiOS has gained popularity due to its affordability and support for popular apps such as WhatsApp, YouTube, Google Maps, etc. It has been embraced by various manufacturers, including Nokia, in their feature phone offering, bridging the gap between traditional feature phones and smartphones. Symbian Symbian was another mobile operating system developed by Symbian Limited and later owned by Nokia. It was one of the earliest mobile operating systems and powered Nokia smartphones in the early 2000s. Symbian features a customizable user interface, support for multitasking, and a wide range of pre-installed applications. However, with the rise of more advanced operating systems such as Android and iOS, Symbian's popularity declined gradually and it was discontinued in 2014. Current trends in operating system. Operating system continue to evolve, adapting to the changing technological landscape and user demands. Let's discuss some of the current trends in operating system development. Cloud integration. Operating systems are increasingly integrating with cloud services, allowing seamless synchronization and access to files, documents, and data across multiple devices. This trend enables users to store their information in the cloud, providing flexibility and accessibility from anywhere with an internet connection. Virtualization and containerization. Virtualization and containerization technologies are gaining prominence in the OS landscape. These technologies allow for the creation of virtual machines or isolated containers that encapsulate application and their dependencies. Virtualization enables efficient resource allocation, while containerization promotes scalability, portability, and easier development of applications. Security and privacy enhancement. Security and privacy have become a critical concern for users and organizations. Modern operating systems are placing a strong emphasis on improving security measures, including robust encryption, secure boot processes, sandboxing, and enhanced access control mechanisms. Privacy features such as granular app permissions and data protection are also being prioritized to ensure user confidentiality. Internet of Things or IoT integration. The prolif- proliferation of IoT devices has led to the need of operating systems that can seamlessly connect and manage the diverse devices. OS developers are creating specialized versions or extensions that support IoT protocols, enabling efficient communications, data exchange, and device management in the IoT ecosystem. Artificial intelligence integration. The integration of AI capabilities into operating system is gaining momentum. AI-powered features such as voice assistant, predictive analytics, intelligent automation are becoming integral part of modern operating systems. These AI-driven functionalities enhance user experience, streamline tasks, and provide personalized recommendation. Edge computing optimization. With the increasing adoption of edge computing, operating systems are being optimized to handle data processing and analytics at the edge of the network. Edge-focused OSs are designed to deliver low latency, efficient resource utilization, and decentralized processing capabilities, enabling real-time and bandwidth-sensitive applications. Conclusion. In conclusion, the history of operating system is a testament to human ingenuity and technological progress. From batch processing systems to modern mobile platforms like Android and iOS, operating systems have evolved to meet our changing needs. Looking ahead, advancement in the cloud integration, security, AI, and IoT integration will continue to shape the future of operating systems, enhancing user experience and productivity. Operating systems are backbone of modern computing, driving innovation and transforming the way we interact with technology. And this is my presentation. Thank you very much.